Hello, my name is Aundobine Tegar, and I'm a UPS student. Today we'll talk about sampling and population. So what's population? Population, these are set of all elements about which we draw conclusion from. So it's like an element. So we often get that out of like maybe example, number of students that did co-op last year or number of all second year political students that got average. So like in form of population is just like what I said is like element that we draw conclusion from. So we have something like population measurement, which is also assigning values of variables to each of every element. And example is like starting salary of EPI student that graded last year can be feasible. So like the term population is just like people, set of people in a particular dynamic. Um, other sample like can be a subset of population. For example, you look at this diagram here, we see that we have 20 people population, and if we want to get a sample, maybe the data is too large for us to get certain specific data from, we can just pick 5 people in form of sample. For example 1000 students graduated from EPL last year. Imagine we want to like get a sample of this thing, so probably we can pick like 10 or 100 students from this sample. um, Sample population relationship. So like I want to give you more understanding of how this work. So for example, suppose we want to like understand the movie preference of 5,000 students in a particular school. Now this data is really large to take. So probably to make it easy, we can just sample out 100 students out of it. So that's how sampling and population work together. So sample population is like a large value, and sample can be like a subset within it. So random sampling. So like this is a process of sample selected from population. Like I said, so is a sample selected from population, and that's so that each population unit has the same chance to be selected like every unit. So there's no partiality here. Each population unit have chance to be selected. Now we have different ways involving sampling. We have sampling with replacement, which involve like you are replacing the value once you pick out another value. Then sample without replacement, there's no replacement, it's a manual value, randomly enter the population and sample with the k unit. And we have the last one, quality sample, which I've not really touched, but like it's probably like a non-scientific which participants select themselves into the value. So first of all, this is sample without replacement. Now looking at unit 3 and unit 4, we see that after picking 10, it was not replaced, and it does not have any chance to be picked back. Looking at it, we picked 7 out of this population. This is the population, this is the sampling. Taking out 7 does not give the chance of 7 to be picked again. And the last one is sample with replacement. We see that we have like a chance of picking 5, even though we took out 5, and the same thing with 7 too. So it's like we are replacing it, and we have systematically evolved. Like maybe we want to pick a two-third of each sampling. So we start from the second one. That's one, two, three. So one, two, three. That's the first sampling. As you can see, two. Then the third, the second one. Then one, two, three. That's the other sampling, and one, two, three. That's the last sampling. So this is done in a systematic form, and we probably use the nth unit. So like picking the third unit of each sampling. So thank you for watching, and I would say I hope you have good idea of the course outline, and see you later.